Good evening once again. Okay. It's my PPT. Right. Okay, so there's one more problem which tells you about finding out the compression in the spring. You have an object of mass 2 kg which is moving at 1 meter per second, and it hits the spring which is connected to this 2 kg block. And as a result of this, so the spring hits it, the spring gets compressed. Okay, this is a problem. Now, most of them, what they do is, I've seen many question papers, answer sheets like this. When they say, okay, this is the energy, there's no friction here, easy way. So the energy associated with this block is half mv square, and this goes in compressing the spring, so half kx square. So they just equate these two, and finally you get this expression. This is completely incorrect. Why? What is the reason? The reason is because, since there's no friction here, when this block comes and hits here, what will happen? This block will compress this. Some amount of this energy is taken, is being transferred to this. Okay, a wave passes like this. Then this energy is given to this block also. Even there is no friction here, which means there's a force given here also. Due to this force, this object will also start moving, which means this object will now compress the spring, while this object will now start moving away, which means it will now start expanding the spring. Expansion is seen. But after some time, you observe that both the objects would be moving at the same speed. Okay. So when they are moving at the same speed, then that is the maximum compression that you can get. Okay. This is how you need to work on. But unfortunately, that fine details, many of them just mistake it. Now let us solve this problem. Okay. So first thing is, an object comes and hits here, which means some amount of momentum is being transferred. So towards it, let us apply your conservation of momentum. Conservation of momentum tells you that initial momentum is nothing but 2 into 1, mass into velocity, plus 2 into 0. Why 2 into 0? Because this is not moving. This should be equal to final momentum. Final momentum, what happens? Which means that when do we consider final momentum? When both the objects are moving at the same speed, right? Which means if I just remove the spring, it's equal to saying two blocks are being connected together and then moving. Okay. So which means it is 2 plus 2 multiplied by V. Okay. Both are being sticking together and moving over here. And don't ask me what happens to spring, right? Because spring will not have any momentum here. Okay. Because it doesn't have any mass over here, right? Okay. So we have this. So as a result of this, the velocity when both the blocks are moving together is nothing but the common velocity, which should be equal to 2 by 4, which should be equal to half meters per second. This is what I get. This is the final velocity. Now what we'll do is we'll apply the conservation of energy. Okay. This is how you need to go. Conservation of energy. How do we apply? What is the initial energy? Half into 2 into 1 square. 1 square plus what is the initial energy of this one? 0. This should be equal to what is the final energy? Final energy is both the blocks are moving at the same velocity, which should be half into 4 into v square. What is v square? 1 by 4. 1 by 4 plus this spring is seen to be maximum compression. So this should be half into k. What is k? K is given to you. K value is given 100 Newton per meter. So 100 into x square. I do not know this x square. So this is what I have. Now it's quite easier. This 2 goes away. This 4 goes away. And now I have 1 minus half. I'll pull this one on the other side is equal to 50 x square. So which means what? Which means 1 minus half should be half. Half should be equal to 50 x square. This implies x square should be equal to 1 by 100. X should be equal to 1/10. What is the unit? Meter. Which means what? 0.1 meter, which is equal to 10 centimeter. Right? 1 by 10th of a meter, 0.10 centimeter over here. So the compression, hence the compression here is seen to be 10 centimeter. Okay. Hope this lecture was useful. So from the next video, That is from tomorrow. We'll be working on center of mass. Okay, after center of mass, maybe a few videos on center of mass, and then I think I might move on to collisions. I've been getting mails of the late to work on collisions and coefficient of restitution and so on. So if I do this, then I think it's fine. Hey, in the meanwhile, you can look at my backdrop here. So this is a website. I have constructed a website. So you can go through it. If you like it, you can let me know. Okay, how do I modify it and so on. Okay, apart from my teaching, I'm also a digital marketer. So I do these things also. You can go through it. Okay, fine. Thank you, friends, for watching and be in touch.